Dive into today's stuff, power function and inverses. Just quick note, by the way, about your tests. I won't have those probably graded till later in the week or possibly in the weekend. I have a couple of them graded, but I won't put them all in the grade book until I have them all graded. So, that being said, you'll get them eventually. All right. You guys, this chapter, we're dealing with powers that are greater than 2. Okay, I guess you could have squareds here. So we've dealt with our linear equations, x to the first power. We've dealt with quadratics, x squared. We're now dealing with x to a power greater than 2. And it could also mean you're having your fractional exponents as well, maybe to the 3/4 power or something like that. So we're going to go through that, talk about that today, and do some review of some exponent stuff and some new stuff as well. Okay? So first, power function, y equals a times x to the power of n. A cannot equal 0. N cannot be n has to be a positive integer. Go ahead and tell your neighbor why a can't equal 0. Show them a reason why, and show them a reason why it has to be a positive integer. Get your attention back up here, please. Thank you. All right, whose birthday we got here? Angelina. Is it your birthday today? Oh, let's sing happy birthday. Way to have a birthday, Angelina. Good job. All right.
We're proud of you. You didn't die.
Define the power function. Y equals a to the power of x, ax to the power of n. Why can a not be 0? Yeah? Yeah, if a was 0, a times x to the power n, that would give you 0 right here. You'd end up with y equals 0. And you don't want y equals 0. Y equals 0 is actually what?
Just the y-axis, or the x-axis.
Oh. Everyone show me with your arm. What is y equals 0? Good. Y equals 0 is the line that does this. It goes that way. Y equals 0, if you have the y-axis, it's at 0 on the y-axis. Crosses there, it's actually the x-axis is the line, y equals 0. Okay, kind of weird. Okay, so we don't want that. All right, that's why a cannot be 0. How come n has to be positive? Cody?
You can't have a negative exponent?
Well, you can. It's just what happens when it's negative. Yeah, it becomes a fraction. If I had, say, y equals a to the x, or ax to the power of negative n, what ends up happening then is that this becomes y equals a over x to the n. Okay? And this is called a rational function. We end up talking about that in chapter 8. Okay? Yeah?
The bottom part's a rational function, or the whole thing?
No, the whole thing, the whole function. Yeah. It's not a function, just the bottom part's an expression. Whole thing put together is the function. Okay. Questions there? So we have to have ax to the power of n. Now, like I said, we've dealt with the first power, we've dealt with the second power. This chapter will be more along the lines of dealing with all those other powers. Okay? And exploring those. All right. 6.1. Power functions. This is a powerful function. Okay? Well, actually, this is just a powerful expression. Okay? 27 to the cubed root of 27. This thing right here, now when we've talked about roots in the past, let me pause so that I have your attention still. We've talked about roots in the past, like if I give you this, you all right?
Yeah.
All right. Square root of 16, whenever you don't see something here, that implies an index of 2. That's a square root. It means two things that multiply to make 16. You guys know that. Okay? You can also write that, however, as an exponent. In fact, it usually is a little easier when you write it like that. 16 to the 1/2 power. Now, the 2 comes from right here, which we usually don't show. But if you don't see any index, any number here, it's a 2. That's the square root. When you write it as an exponent, that 2 goes down here. So where in the world did the 1 come from?
The radical.
The radical? Yeah, there is one radical. Pretty radical.
The 1 and the 16.
Well, let me tell you this. If I put this right here,
Oh, it's 'cause it's the
this
root
would
of
now
3.
become a 2. And if I put that right there, that would now become a 3. Okay? What's another way of writing 16 times 16 times 16?
16 cubed.
16 cubed. So 16 cubed, the square root of 16 cubed is actually written out as the 16 to the 3/2 power. So whatever the denominator is, that's what your radical is, what root you're taking. And whatever your numerator is, that is what you're doing inside the radical there. Yeah?
So for the first one, the root 16 without an exponent, it's just like 16 to the first power, right? So
Yeah, 16 to the first. Yeah, like when we just had this, that is 16 to the first power. The square root of 16 to the first power. We just don't show the 2 because it's implied, and we don't show the 1 because it's implied. All right, how many are with me? Okay, bless you. All right, so if I'm taking the cubed root of 27, that means what number times itself makes 27. This also could be written as 27 to the 1/3. Okay, cubed roots are ones we should know. Like you're good with perfect squares, 1 times 1, 2 times 2. You can count by squares. So next time you're bored in, hopefully not math class, maybe it's
English.
yeah, well, I wouldn't say, I don't say we're bored in English. English is amazing. Maybe it is one of those other classes, though. Okay, maybe you start counting by cubes. You know? So you just start, you're like 1 times 1 is 1, or 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3.
27.
Hey, dude, 3 times 3 times 3 is 27. That means the cubed root of 27 is 3. Okay? Any questions there? Notice 8 squared, the cubed root of 8 squared, that's 8 to the 2/3 power. Now, it doesn't matter order operations wise here, which you do. You could actually take the cubed root of 8 and then square it. Or you could square 8 and then take the cubed root of it. I personally, like if this is a perfect cube, which 8 is, the cubed root of 8 is actually 2, right? Because 2 cubed is 8. If I took the cubed root of 8, which is 2, I now have 2 to the second power. And 2 to the second power is 4. Now you could have also said 8 squared, which is 64, and the cubed root of 64 is actually, it's also 4, right? Because 4 by 4 by 4 is 64. Order doesn't matter there. No matter what, the answer is 4. All right. Does anyone know the next perfect cube?
125.
125. How about the next one? 216. How about the next one?
You look different after that.
Okay. That's 5, 6, and 7. Okay. You guys just keep going from there. All right. Any questions? All right. Without using your calculator. Actually, I'll let you get caught up on your notes real quick. Okay. Then I don't want you to have your calculator being used yet. Without using your calculator, I want you to complete number 3 on the example side of your assignment. Numbers 3 and 4 without your calculator. Evaluating roots and powers. There you go. So what do we get for number 3? 2? Same thing as the 4th root of 16, right? Which is equal to 2. Right? Because 2 times 2 is 4, times 2 is 8, times 2 is 16. So this answer is 2. This is saying what number times itself 4 times is 16. Okay. How many get that?
No.
No?
Makes no sense at all.
I don't understand.
No sense at all?
Makes some
It's
Like,
just
it
2 to
makes
the
some
4th is
sense.
16. So then it's like, what to the 4th is 16?
So do you understand that the 4th root is asking what number times itself makes 16? times itself
Why don't
4
you
times.
Just divide it by 4 and then use the radical.
Divide the 16 by 4,
No,
which is 4, and then take the square root.
no.
It doesn't always work like that, though.
Like it-
Okay? Just so happens that it would work on this one. Yeah,
So you take the square root of 16, which is 4, and what do you do after that?
you don't take the square root of 16.
Oh.
This is asking, this right here is saying, give me the same number multiplied together 4 times to make 16. So like you could try it, you could guess and check. 1 times 1 times 1 times 1, which is 1. That didn't work. 2 times 2 is 4 times 2 is 8 times 2 is 16. It's 2. So that's what it's saying. It's saying, what can you multiply by itself 4 times to make that thing? Yeah.
So are we just supposed to guess and check?
Yeah, you can use eventually you'll memorize that. Yeah. But yeah, for now it'd be just guessing and checking. Now there are ways to kind of narrow it in, and we'll see that on 86. Okay, the only other way to do this one is if you know your perfect fourths. You know, your power of 4. Like if you counted by, I mean, you have 1 times 1 times 1 times 1, which is 1, 2, and 16, and then 3 times 3 times 3 times 3, which is 81. 4 times 4 times 4 times 4, which is 256. 5 times 5. Now I'm figuring these out as I go. I don't have these memorized. Does everyone know how I'm doing this? 4 times 4 is what?
16.
So 16 times 16 is 256. 5 times 5 is what? 25 times 25 is 625. These are to the 4th power. This is 1 to the 4th, 2 to the 4th, 3 to the 4th, 4 to the 4th, and 5 to the 4th. Do you have to memorize them? I don't expect you to memorize those. I maybe hope you could get to those pretty quick. So yeah, Emily, you're kind of guessing and checking on that. Okay. Let's try number 4. Number 4, this saying in radical form, this saying, what is the cubed root of 86? That's really what it's asking. So if I think back to my perfect cubes, 1 cubed is 1. 2 cubed,
8,
3 cubed,
27,
4 cubed,
64,
and 5 cubed.
125.
All right, so this number 86 falls between this whole number and this whole number, 4 and 5. Right? 84, the cubed root of, 86 is right in between here. It's actually closer to 64, right? 86, sorry, thank you. Okay, it's actually closer to 64, correct? So my answer is probably closer to which whole number?
4.
4. In fact, it's almost in the, probably like 4.4-ish. Right? I mean, the cubed root, I'm saying it's about 4.4. Everyone get your calculator. It's not quite the middle, so if you need to borrow one, go grab one now. Okay, I want you to do the cubed root of 86. No, you can be helping the people around you also, but just a quick calculator lesson. Okay. First, if I'm doing 86 to the 1/3 power, if you go 86 and if you use this little caret symbol right here, on this calculator, it automatically jumps you up to the exponent position. Now, how many of you have a calculator that does that when you use the caret symbol? Does anyone have a calculator that does not do that? Hannah, can I borrow your calculator for a second? Okay, thank you. I'll bring it back to you here in a minute. Hey, if you have it this one, it's easy. You just push the little caret symbol, and when I'm saying the caret symbol, that's this up arrow right here. Okay, you push that, and you go 1 divided by 3, and you're in the fraction up there, and you hit it, and it's 4.41. So we're darn close, right? All right. Now, if you don't, so notice this one, if I put 86, and I got the caret, and we go to 1 divided by 3, that does not give me 4.41. Because now here's what I see as a teacher. You guys, You guys, I'm sitting up here describing this because, is it because I don't get it?
So we don't get it.
Nothing.
No, it's because you guys don't. And now we're this far into a semester. When I'm looking out here, I look at everyone. I'm watching all eyes real quick. I do a quick sweep with my eyes. But then I start just quickly glancing back and forth. And then I start, the second or third time I go through, I'm looking at the students that I know struggle, either because they don't pay attention or they just struggle with the material. And some of you are always, even you're struggling, you're still paying attention. But some of you, especially ones that, like, maybe you're just struggling and you don't ask for help, or you just start not doing as well as you want in class, you're staring off into space. And I'm trying to point out a mistake you would make, and you think you're doing everything right. Like, look, I want 1/3 power, McCoy, I got it right. Okay, but when you tune out just for a few seconds when I'm talking, you miss out that, hey, the problem here is your calculator follows order operations. And it's doing a power first, and then it's doing division. So it is raising this to the first power, and then it's dividing by 3. Okay? So this is actually saying 86 to the first, which is 86 divided by 3, which is 28.66666666. You would actually have to, if your calculator does this, you would actually have to input that inside parentheses. And then it gives you the correct answer. Understand how to program. That's number one. Number two, if you have this style calculator, your operating system's old if it won't bring it up there. So we can upgrade your operating system, then it goes to that on an 84 plus. And that's easy. I just hook it to one of my calculators and move the operating system over. Okay? But if you have an 83, you can't upgrade it, and it'll be in this form. You'll have to do that. Some of the scientific ones, you have to do that. Okay? Very good. Thank you, Hannah. There's another way. Yeah?
I turned my calculator on and it's in Spanish.
See. All right. Well, that's good. Maybe get some extra credit in your Spanish class. Either that or go borrow another calculator. Just set that one on my desk. Is that one yours?
No,
That was mine. Okay. See. Hey, actually, here, why don't you fix it real quick? We'll go out of Spanish. You go, just hit mode. Your keys didn't change to Spanish, did they? Just click mode. And let's go down to where it says, oh, that's a lot of stuff, dude.
Hers is in Spanish. Don't forget about that.
Yeah, she's gonna figure it out.
Oh, yeah, let's not do it here. I'd have to go to catalog, so just grab another one for now. Hey, the other thing you can do is you can click the math key. So everyone find math. And now we can do the cubed root. Now the cubed root, there's actually option 4 here. On my calculator, it has an actual cubed root symbol, right? Okay, so if we select 4, and it puts a little cubed root there, and then we can put 86, and it still gives me 4.41.
Thank you.
Now, if you were doing a root bigger than 86, like maybe the previous problem where we had 16, the 4th root, if you wanted to do that one, we could go and select math, and actually option 5, notice that says the x root. Well, on some of these calculators, when you select 5, it actually gives you, we found this out last period, it gives you the chance for you to put in whatever number you want there. Some of yours don't do that. You actually have to put the root in first. So like on this one, I can put that, and I can select 4 and then arrow over and hit 16, and it gives me 2. Some of yours, you actually have to push the 4 first, and then go to math, and that, and then it inputs it there for you. And 16, and hit enter, it gives you 2. So it's the 4th root. Anything greater than a cube. Yeah?
Is there any way to get rid of the answer thing? Because every time I try to do it, it just puts the answer right there. It's like answer.
You can move over and edit it yourself.
I know, but is there any way to stop it?
I don't know what you're talking about.
Eli, you put 4 first and then do it. That's
No,
on the
like,
calculator.
I know I can do that, but
Okay, well, I'll help you in a minute.
I have to move it over by myself, but it's really easy.
How did you get there?
I just hit the button.
Well, you got to put the number first then.
No, it's because. Okay,
So if you hit the number
Okay.
first, then
Then it automatically
never
goes
mind.
up there.
Never
That's-
mind.
That's exactly what he was just saying.
never mind. I know that's okay.
Okay.
You
All right,
guys
well, I'm
don't
glad I
understand
showed.
what I'm saying.
I don't understand, but that's okay. I can help you in a while.
If you just yell at me random crap, I'm not gonna make sense.
Dude, relax.
Just go.
Man, don't be such a grouch. All right, number 5. Everyone try number 5. Give it a shot.
Ready?
Well, since most of you used your calculator, hey, the couple ways I want to go about this. First, I want you to see that 4 1/5. We can actually change that to 21. 5 times 4 plus 1. 21/5. Now, how many of you remember that? Doing that. This 4 means I have 4 5/5 or 20/5. Plus 1 more fifth is 21/5. So 21/5 all to the 5th power. The properties of exponents, this goes into there and it goes into there. That's 21 to the 5th over 5 to the 5th. Okay? 21 to the 5th. I usually do that in my head. But today I think I'm just going to use my calculator. All right. 4084101. I'm just joking. I can't do that. 5 to the 5th. I could actually do that in my head. The other way you can do it, by the way, is like that if you want to type it all out.
Ew.
Yeah.
I totally
3125. Okay. And then you could divide it. Now that's kind of the long process. Right? If I actually divide those, what do I get?
1,306.91232.
Okay. All right. Now, how many of you just input this into your calculator? Did anyone input this into your calculator? Did anyone do the division and then raise it to 5? Okay. Well, there are a couple ways. First, you can put 21 over 5 into your calculator and raise it to the 5th. Now, is that going to give me the correct answer? What is wrong with that? Go ahead and tell your neighbor. Quick error analysis on your calculator. What's wrong? Okay, volunteer. What's wrong? Cassie? Good. It's going to raise the 5 to the 5th, not the 21. So really what I need are parentheses. Okay? So we insert these parentheses here, and we've got it. There we go. That's the ... All you yawning out there, don't sound too excited. Okay? Yes. All right. So we've got it. Very good. The other route, for those of you who want to put 4 1/5, if you have a newer, a TI 83 or an 84 plus, or an 84 silver, you could hit alpha and then any of the first couple keys up here. And it opens up these other menus. Okay, there are these tabs here. I have 4 tabs on mine.
Wait, how'd you do that?
Okay, you hit alpha, and then whatever up here. And now last period I made the mistake of assuming, and that's a bad thing, this n over d means numerator over denominator. This u means you have a whole number. For instance, 4 and 1/5. So if I hit option 2 would give me the chance to put the 4, put the 1, put the 5, and then I'd have to raise it to the 5th. Now I should really put, it does. I think it raises that whole thing, yeah. So it inputs the parentheses on mine. Okay, does it do that on yours, Jordan?
It does not.
Okay, so you have to put the parentheses.
Yeah.
Okay, so it's probably a good habit, even if you use that, to get those parentheses in. Anyway, depending on the calculator, if you don't see the parentheses, you should put them in. Okay. Oops. Hey, and it converts it. Nice.
Where is China?
It does not give me
All right.
very
Any
on
questions there? Hey, the last way you could have done it, 21 divided by 5, all raised to the 5th power.
That's so much faster.
That would have worked as well.
Could you do 1/5
Okay.
times 4?
All right.
4 times 0.2.
So that's what Eli's asking. 1 divided by 5 times 4, all raised to the 5th power. Did that work?
Why?
I didn't say anything.
Because this is saying 4/5 then.
Slam.
Okay. That didn't work. All right. Yes. Sometimes. Some you won't be. I'll let you know though. Know how to do it both ways. Okay. Now, if you're not allowed to use your calculator, they're going to come out to pretty easy, pretty good answers, like this one. Do number 6 without your calculator. those of you struggling, a quick hint, when you bring this in, you're actually multiplying 8 to the second times 1/3. So that really means 8 to the 2/3. Right? And remember, the top number is, like if you wrote it like this, what are we doing outside? Cube root, and inside squaring. So that's saying, what is the cubed root? Is 8 a perfect cube? Yeah. What's the cubed root of 8? 2, and then square the 8 is, or square that is. That's 4. Okay? Or 8 squared is 64, and the cubed root of that is 4. Answer's 4. All right. Everyone rate themselves 1 to 5.
I have the cube root of 125.
Oh, very good. That's pretty good. Okay. All right. I saw some 3s out there as well, so I want you to ask your neighbor if they need help real quick before we move on to the next thing. I'll be walking around. Number 12, number 12 and 15, we're going to find the inverse of a function. So I want you to work on 12 and 15 right now on your own based on what you remember about inverses. Spend a couple minutes going through those two. Okay, by the way, your assignment tonight is 3 through 20.
On what side?
Example side, 3 through 20 all. So we've already done, you're going to have 8 done before you leave. 8 of those problems. So it's not a huge chunk. Okay?
Thanks, man.
Try number 12 and 15 right. Okay, well, let's check it out. So first thing you need to do is switch x and y. How many did that? Okay, very good. Next thing you need to do is get y by itself. How do you get rid of a 2/3? 3 halves. 3 halves? Everyone agree? The reciprocal. Multiply by the reciprocal. Okay, that cancels that. That cancels that. 3 halves. We get 3 halves. X equals y squared. How do you get rid of the squared? Take the square root. Whenever we impose a square root, plus minus. Now, I'm not going to have us rationalize that. I'm going to let you leave it like that. Okay?
Oh, just kidding.
What would it look like rationalized?
I'm not going to go through rationalizing. I'm going to confuse you enough here in a few minutes. And I don't want to go through it right now. Okay? So, I can check yours in a while if you want. If we have time. We're going to run out of time otherwise. Okay? All right. You don't have to scribble it out.
No, I put a line through it, and then you said that. I'm like, oh, well, at least you can still read the line through it.
All right, number 15. We good? Any questions on 12? Okay, 15. Hey, first thing, switch x and y. How many made it that far?
I did.
All right. Next thing, times 5. Good. So we get 5x is equal to the cubed root of y. Next thing, cube it. Okay? The opposite of cube rooting something is cubing it. That gives us y is equal to 5x quantity cubed. Now, it's important to have that quantity cubed because we have to bring that cubed into each part. That's 5 cubed and x cubed equals y, which means y equals 125x cubed. Make sure your power looks like a power, not like it's just another number sitting by x being multiplied there.
Can we put the little caret, like if we're doing...
No, don't put the caret. Okay? Other questions there? Yes?
Why wouldn't we do 5x times 5x times 5x?
You do. But 5x times 5x times 5x is 5 times 5 times 5, and x times x times x. 125. Yeah. Other questions? All right, let's look at 16. I want everyone to copy it down.
Thank you,
I
no.
have a question.
Yep.
On our the sheets that we use, you know, like the graphing portfolio sheets, are we allowed to cut out pieces of our notes and put them on there?
No, but you can write notes on there.
So
Write 16 down.
So that means I could like literally just take this and rewrite it perfectly the exact same way.
Sure.
But I can't glue it on.
No. I know.
That is lame.
It is lame. Okay. Switch x and y. First step is to divide by 1.6. Now in math, it's a poor form to have a decimal in a fraction. That is not good. Therefore, I am going to move this over by multiplying it by 10. So rather than 1.6, it's going to be 16. So I'm going to multiply this by 10. Everyone with me? Yeah. So that's going to now become 10 over 16x. Yes.
Would you have to multiply the other side by 10?
I don't have to multiply the other side by 10. Okay? I'm sorry, I'm not multiplying by 10. I'm multiplying by 10 over 10. Boy, that's a faux pas there. Sorry, my bad. Hey, 10 over 10. So that's a good point, Nick. If I just multiply by 10, I have to multiply the other side by 10. It should be 10 over 10. So I'm multiplying by 1, but in the form of 10. So now I don't have that decimal. So that's equal to y plus 1 cubed. Everyone with me?
Mm-hmm.
What is 10/16?
5/8.
That's 5/8. So I have 5x over 8 is equal to y plus 1 quantity cubed. Next step. Yeah?
Multiply by 1/3.
No.
Or 1/3. The power
Cube
of
root
1/3.
it.
I could multiply the power 1/3 or
Cube root it.
cube root. So I'm going to cube root it. Power 1/3 would work as well. If I cube root it, I'm taking the cubed root of 5x over 8 is equal to y plus 1. Now please note that when you're taking the cubed root of a fraction, that means the cubed root of the numerator over the cubed root of the denominator. The root of any fraction is like that. How does that help me? Well, the cubed root of the denominator is 2. That part becomes 2. So I'm left with the cubed root of 5x over 2 is equal to y plus 1. Now, when I impose the cubed root, did I need to put plus minus?
Yes. I thought so.
Let me ask you this question. Actually, let's finish this problem real quick. I need to subtract 1 over, right? So when and I'm actually going to put -1 out in front. The answer, by the way, is no. You don't have to put the plus minus. And to show you why, just a quick side problem.
Oh, 'cause, yeah.
If I have x cubed equals 27, and I take the cubed root of both sides, that actually means that x is equal to 3. Now, I impose the cubed root by doing that. So I'm saying, well, to get rid of that, I've got to impose a cubed root. If I put plus minus, that means my answer now is plus minus 3. And if I plug that back in, 3 times 3 times 3 is 27. However, -3 times -3 times -3 is -27. You only put plus minus if you're doing even roots. Odd roots you don't. All right.
That's odd.
Yeah. You guys, last problem.
2 minutes.
Yeah, I know. 2 minutes.
Let's go. Crank it out.
Can't see it.
We can't see it.
This is anarchy.
I love you, but
Yeah, you don't have to do it. Pack up.
Can you say it for
I know
class
how to
and
do it. Okay, divide by 0.6. We get x over 0.6 equals the 4th root of 2y. Can I keep it like that?
No.
no.
Because it's a
No.
decimal.
10 over 10, so that becomes...
5x over 3.
No, let's not reduce it. 10x over 6 is equal to the 4th root of 2y. Now we can reduce to 5x over 3. How do I get rid of the 4th root?
Cube. Or
To the
4th power.
4th power. So 5x to the 4th, the whole thing to the 4th, and 3 to the 4th equals 2y. 5x to the 4th is 125. X to the 4th over 81 equals 2y. Next thing is to divide by 2.
It's 625.
Huh? Oh, 625, thank you. Hey, when we divide by 2, that's the same thing as multiplying by
1/2.
1/2. All right. The answer right here, multiply it by 1/2. There we got it. Dude. Woo!